Hello! Today we are solving a real FE exam problem from 2025 fluid mechanics, the resultant force on gate problem. A rectangular gate with dimensions 5 by 4 is resisting a fluid which has a density of 1500 kilograms per meter cube. The resultant force that is resisting is acting at the top of the gate, F you see over here in this diagram. So what is F is the question. So let's look at a free body diagram to understand this question first. We have a gate which is resisting a fluid. So let's say the fluid is applying an average force of Fp on the gate and the gate is resisting with a force Fr from the top of the gate. If we are able to find out the relationship between the resisting force Fr and the pressure force from the fluid Fp, we will be able to crack this problem. So what is the relationship? In order to understand the relationship between these two different forces, we need to understand their positions first, because we can't do equilibrium of forces if they're not acting at the same point. Now Fr we all know is acting at top of the gate, but where is Fp acting? Now I want to tell you about the concept of the pressure diagram of the fluid. Though the fluid is looking like it's equally distributed across the entire gate, the pressure acted by the fluid on the gate is not consistent. At the top there is pretty much no pressure acting from the fluid on the gate, but at the bottom the maximum pressure acts upon the gate. You might wonder, how do I know this? Correct? Let's look at the basic pressure formula. P is equal to rho g h, where rho is the density, g is the gravitation, which are both constant, and h is a variable height, because at the top h is going to be 0, at the bottom h is going to be height of the entire gate. I hope that clarifies why this pressure is a triangle and not a rectangle from the get-go. But since it is extremely difficult to calculate the force of pressure from a triangle, we are going to convert this triangle into a comfortable rectangle. And how am I going to do that? You might be wondering. Let's come to that. Because the height at the top is equal to 0, the pressure at the top will be rho g times 0, which is nothing but 0. The pressure at the bottom, however, will be rho g times h, which is rho gh. And if I find the average of the top point and the bottom point, it is going to be rho z times 0 plus rho g times h divided by 2, which is nothing but rho g h by 2. So if you put any point on the top and average that pressure with the same relevant point at the bottom, you will always get rho g h by 2 across the entire gate. Got it? You can get a point from here at the top and exactly find a relevant point here at the bottom, and if you equate the pressures at both these points, it's going to always end up as rho g h by 2. So simply put, you can say pressure is equally distributed along the whole gate as rho g h by 2. Okay, so that is going to be my average equally distributed pressure. Got it? Now if I substitute this average pressure in the equation at the top, remember this equation, the potential energy conservation equation that we just spoke about? If you substitute Fp, all I have to do is calculate the height at which Fp is acting upon. Only for our convenience, I have converted the pressure triangle into a equally distributed rectangle, but in reality it is still a triangle. The resultant of this pressure triangle Fp will be acting along the centroid of this triangle. So where is the centroid of the triangle located? It is located at a height 1/3 times the height of the triangle. 1/3 times the height is nothing but h by 3. So hc is h by 3. Got it? Now if you substitute this hc over here, and we already calculated Fp through the average distribution of pressure, we already know what the height is from the question, we'll be able to simply find out the resultant of forces Fr. As simple as that, guys. So let's get into the nuances of solving this problem. Fr times h is equal to Fp times hc. That is the basic equation. Fp is average pressure times area of the rectangular gate. Average pressure from the previous page is equal to rho g h by 2. The height of the rectangular gate is nothing but 5 meters. You can substitute that in this equation over here. So h is equal to 5 by 2, that is 2.5 meters. Now that you know height, next thing to calculate the pressure, we need to know the density rho. Rho is nothing but, from the problem, 1500 kilograms per meter cube, and g, the gravitation in SI units, is nothing but 9.8 meters per second square, and h, the average height, is nothing but 2.5 meters. So based on this, the average pressure can be calculated as 1500 times 9.8 times 2.5, which is 36,000 750 kilograms per meter second square. The units are very important, guys. So what I always do is, for everything that is I'm substituting in this particular problem, I always write their units, and if there is something that is to be cancelled out between different units, I cancel them out. For example, here we have a meter in the numerator and we have another meter coming from the height, and we have a meter cube in the denominator. So that cancels out and become a meter in the denominator, correct? We also have a second square in the denominator, which came as meter second square in the denominator, and the kilograms in the numerator stays. So that's how we got the units here as kg per meter second square. Pay attention to the units, because sometimes in the exam, that is what makes the difference between a good solution versus a messed up one. So based on this, you already calculated the average pressure. Now if you substitute the average pressure into Fp, you get Fp as pressure times area of the rectangle. So pressure times 5 times 4 meter square, which is all of this you see over here. And once you solve it on your calculator, you get that answer as 735,000 newtons, which is 735 kilonewton. Got it? So now that you found Fp, we are going to substitute in the potential energy conservation equation over here. Got it? This is the most important equation. Please remember this. Okay. So simply put, Fr is equal to Fp times Hc by H. We already know that Fp is 735 kilonewtons, Hc is H by 3, which is 5 by 3, that is 1.67 meters, and the height is 5 meters. So solving everything on your calculator, you get the answer as 250 kilonewton. So going to the question, that is going to be option number A. So in order to solve this problem effectively, here are the things that you need to remember. For problems like this, where a gate is resisting fluid, the potential energy is conserved because the forces are acting at different height, one at the top of the gate, the pressure force at the centroid of the pressure triangle. You cannot directly do equilibrium of forces. You need to use potential energy conservation equation like this. So Fr times the height of this gate is equal to Fp times the force at which the pressure is acting, which is nothing but the centroid of this triangle, which is nothing but Hc is equal to H by 3, 1/3 times the height. So once you substitute Hc, which is centroid of the height, and height H, which is the height of the gate, all we got to find is Fp, which is force acted by the pressure of this fluid. To calculate Fp, we multiply the average pressure times the area of the rectangular gate. Please understand that the average pressure and area of the gate are perpendicular to each other, and average pressure can be calculated by using the basic formula of pressure, which is P is equal to rho GH. I need you to understand that rho is the density of the fluid, G is the gravitation, and H is the height at which the pressure is being calculated. So if you measure at the top, the H is going to be 0. At the bottom, H is going to be H. Since we want the average pressure and not variable pressure, I'm going to average the pressure at the bottom with pressure at the top, which makes it rho G times 0 plus rho G times H divided by 2, which is rho G H by 2. So for every single point, if you average the pressure at the top and bottom, it will always end up becoming rho G H by 2 for the entire rectangular gate. So simply put, you can say that the pressure is equally distributed along the gate as rho G H by 2. Now this average pressure can be substituted, and AV is the area of rectangle, which is 5 times 4 from the given of the problem. So once you substitute all of this into this problem, you are going to end up getting the resultant force Fr is equal to 250 kilonewtons. As easy as ABC.